Hello students, today we are going to look at length of non-straight line. So we will look at circumference and arc length in this case. So don't forget that in a circle, if this is the center of the circle, then you have what is called as radius, and radius goes from the center of the circle to the edge of the circle like this. So this is called radius. What we call diameter has to pass the center of the circle, and it goes from edge to edge. So in this case, it has to pass the center and then it goes from edge to edge. Okay, so diameter is actually the longest line or segment you can draw inside a circle, because if you, for instance, draw a line here, then of course it's actually shorter than the diameter. All right, so the formula for circumference of a circle, so circumference means the length of the whole circular side of the circle here. Okay, so the formula is 2 times pi times r, which is radius, or you can also use pi times d, and d in this case is diameter. And of course, you know diameter is twice the length of radius, so that's why here in this formula 2r is the same thing as diameter. Okay, now we are going to try and see the formula for arc length. And what does that mean by arc length? So in this case, let's say this is the length that we want. So obviously it's only a part of the circle. And let's say here we know the size of this internal angle. We will call it theta. It's actually a Greek letter which is usually used to represent angle. So let's say the size of the internal angle is theta. And of course we know one round in the circle, the angle is 360 degrees. So we know that this length of this arc is only a fraction of the circumference of the whole circle, right? And how big a fraction depends or proportional to the size of this internal angle. So it will be proportional to the angle theta out of the whole round in the circle is 360 degrees. Okay, so this is the fraction, how big the fraction is of this arc proportionally to the whole circumference of the circle. So that's very easy then to find the yellow arc length. You basically just have to multiply this fraction theta out of 360 degrees, and you multiply that by the circumference of the whole circle. So basically it's just the same thing. You have two formulas because you have two formulas for circumference. So it's basically just the same thing. It's just theta out of 360 degrees multiplied by 2 pi r, which is the whole circumference of the circle. Or another formula will be theta out of 360 degrees multiplied by pi times diameter. So let's try and use the formula that we already know now to find the length of the minor arc DE. And you see here on the next question later, we will do the major arc. So what does this mean? The minor arc will be a smaller part here, because you see that this circle is now by segment DO, if you want to call it O, at the center of the circle. And OE, we have this internal angle 160 degrees. So the smaller arc is called the minor arc. And later on, the major arc, what we want is actually this part here. Okay, so let's try to use the formula that we have just learned. So here the length of the minor arc DE will be just 160 degrees over 360 degrees, and then we multiply it by the circumference of the whole circle, which is in this case 2 times pi times 8. 8 is the radius of the circle. Okay, and then we can use our calculator for that. You know that this button gives you the fraction, and we can just type 160 over 360, and we can do this all in one. So we will type 160 over 360, and then you have to be careful here. This part here, now you are there, so if you want to go out of the fraction, you have to click this right cursor, and then we will multiply that by 2, and then pi, and you should know the pi button is here, so you have to press shift and then 3 to get the pi button, and then we multiply that by the radius, which is 8. So 22.34 to 2 decimal places, and the unit is in this case meter. Okay, all right, so for the major arc we will use exactly the same formula. However, you should realize that the internal angle now is not 160 degrees anymore. So the angle that we will use for theta is this one here. And of course, you know that the whole circle is 360 degrees, so this angle here must be then 200 degrees. From 360 subtract by 160. Okay, so then in this case we will have 200 over 360 multiplied by 2 pi r, and r in this case is 8. So we will try and use the calculator again. I can copy this actually, and then the only thing I have to do is to replace the angle by 200 instead of 160, and then the rest is the same, 2 times pi times 8, and press enter. 27.925, so to 2 decimal places it will be 93, because this is 5. Okay, 27.93. So 27.93, and the unit is meter in this case. In the next question here, you are asked to find the perimeter of the figure, and then you have to be careful because the figure has 3 sides, 1, 2, 3. So 1 is the arc, 2 and 3. So first we are going to find the arc length, and what we mean by arc length is actually only this part here, so you have to be careful. Okay, so the arc length will be then 100 over 360, and then multiplied by 2 times pi and times the radius, in this case is 10. So you see, can you imagine that this is just a sector, a part of a circle, and the whole circle will be like this, and here the internal angle is 100 degrees. So in that case, if this is the center of the circle, then this will be the radius of the circle. So the radius is 10. All right, and the unit will be centimeter. Let's use our calculator. So you see here, I actually only copy what I have done before and just replace the number that I need. So 100 over 360 times 2 times pi times 10 in this case. So you have 17.45. 17.45, and the unit is centimeter. So again, you have to be careful that what we have just found is only the arc length. So when you are asked what the perimeter is, then we still have to add, of course, this side, which is 10. Well, how do I know this 10? Because of this sign, but also because they are both radius of the circle, and radius is always the same length. So I have to add 10 and 10 in this case of those two sides. So altogether we will have 37.45 centimeter as the perimeter of the figure. Try to practice with the questions in the packet, and if, let's say, in the packet there is nothing said about minor or major arc, then you can safely assume that what is asked is whatever length which is opposite the angle given. Okay, good luck.